All right, welcome, Michael. I'm going to give you a quick intro to your first lesson, 7.00, the intro to probability. And a weird twist, our last unit of calculus was actually probability. I didn't expect it. I didn't see it coming. I didn't know it was coming. But I'm going to walk you through the world of probability as quickly as possible. So you'll have a Desmos. I'll do some of it with you. You can then go there with the link that I provide to finish up as much as possible. We're going to skip problem 1, so I'll set our pacing for problems 2 through 6. Anyhow, okay, let's take a look at what you're looking at. Problem 2 goes over some definitions. So with probability, we're going to be talking about things that happen seemingly at random throughout our world, right? Things that even though we know kind of how probable something is, we cannot predict with certainty. Okay, and that's what a random experiment is. And even though we might know, a little bit about it, if it's truly random, right, there's always that chance that we could still be wrong or something can happen that is outside of what is probable. The sample space is associated with a random experiment is the set of all possible outcomes. So just like what are the different possibilities that can happen. Now with flipping a coin, that is obviously to me random, because I cannot predict what's going to happen. I can know the sample space is heads or tails, and I know that I got a 50-50 chance, but I don't know anybody in the world that's like a better coin flipper than somebody else if they're doing it the right way. Okay, so that means it's a random experiment. If we use the word event, that's one of the possibilities. And we can write, the probability of that thing happening would be P of E, whatever that thing is. Okay, and we're going to write this as a fraction, but I'll go over that. And the first example is a fair coin has 2 sides, heads and tails. You know this, that are equally likely to show when the coin is flipped, which is necessary information. And so we want to know what is the probability that the fair coin lands on heads. Okay, so all we would do is just basically say, hey, the probability of the coin landing on heads is, well, what? Let's see. Probability is number of successes, total number of possibilities. Well, first of all, I'm going to start with our total number of possibilities. There's 2 sides to a coin. Well, how many of those ways would be considered a success? Well, only if it lands on heads. So how many of those sides have heads on it? Well, only 1. Okay, so what we have here is a fraction, and we're going to represent probability as a fraction over and over again. We could always turn this into a decimal, 0.50 or 0.5, and a percent by moving that decimal over twice, 50%. All 3 of these represent probability. We're going to be focusing on fractions, knowing that we could always plug that into our calculator to find the rest. Okay, let's go on to slide 2, and let's take a look at some more examples. Example 2. Now we have heads, tails, a die is a very random thing, but also rolling dice. Okay, so there's nobody out there that, is a good die roller or dice roller. So that's a random experiment. Let's find the probability of something. What's the probability of rolling a 1? And what's the probability of rolling a 2 or 5? All right, 2 different things here. Probability of rolling a 1. We would say probability 1. And what I would do here is I would first construct a sample space. Well, I know that on a 6-sided die that I have 6 total sides. There are 6 possibilities, right? The numbers 1, 2, 3, 4, 5, and 6. And out of those, how many of those are a 1? Well, 1 of them. And now, when I went over this problem, maybe this is a bad example to start with, because some people say, well, the probability of 1 is 1. So what's the probability of rolling a 2? Is it 2? Probability of rolling a 3? 3? No. It's the fact that there's only one side of the dice that has a 1. There's only one way to roll a 1. So out of those 6 options, only 1 is a 1. So there's our probability 1/6. What's the probability of rolling a 2 or a 5? Well, we're going to forget the word or for a little bit. Let's move on to the next page. Great. The next one, problem set A, part 1. A box contains 8 white, 6 black marbles. And what we're made to believe that these marbles are maybe equal size, equal texture in a box that hides their color. So if we reach into it, we truly don't know what we're grabbing. The box is shaken up. And so what we've done is we maybe can create a random experiment, so to speak. First thing I want to do is I want to create a sample space. And so what I could do is I could just include everything that's in there. I got 8 white and 6 black. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 8 white and 1, 2, 3, 4, 5, 6 black. And in there, what I have is basically each letter represents one of those marbles. And so I know now, just kind of looking at this, what's in front of me. And so now I can find the probability of selecting a white marble. Well, once again, we need to set up a fraction. How many total marbles are there? I just found that there are 14. Even though there's only 2 different colors, how many different things could I pick from down there? 14 of them. So we're thinking of those individual things there, right? There are 6 sides on a die. There's 2 sides on a coin. And in this case, there's 14 marbles. And out of those 14 marbles, how many of them are white? Well, 8. And of course, we could always reduce this if we want to make this 4, 7. And then, of course, now selecting a black marble, we're still talking about 14 marbles. How many of them are black? 6. I can count them for my sample space, or it just tells me. I can reduce that. That would be 3 seconds. Okay, let's move on. Let's see. I want to make sure I leave something for you. All right, we've got some more marble problems. Great. This next one. Now we've got an 8-sided die. We want to construct a sample space using an 8-sided die. I think those exist. They're little funny shapes on each side, I believe. And so we have a 1, we have a 2, we have a 3, we have a 4, we have a 5, we have a 6, we have a 7, we have an 8. I'm made to believe that an 8-sided die counts from 1 to 8. Well, this is a truly weird 8-sided die. I know they exist, but this is what I'm made to believe. Find the events that correspond to the phrase, an even number is rolled. Well, how many of these on the 8-sided die are even numbers? Well, 2, 4, 6, and 8. There's 4 of them. Notice how it didn't ask me for the probability, it just said find the events. All right, so I'll say 2, 4, 6, and 8. Those are the events within the sample space. There's 4 of them. What is the probability that an even number is rolled? Well, how many even do I have? I have 4. Out of how many total sides on the die? 8. So we have a 4/8 chance, which of course can reduce to 1/2. So we got a 50-50 chance of rolling an even number if we have an even or an 8-sided die with numbers 1 through 8 on it. And now let's do D and E. Find the total events that correspond to the phrase, a number greater than 2 is rolled. Okay, well, how many of these are greater than 2? Not greater than or equal to, just strictly greater than 2. So we got 3, 4. We're going to create 3, 4, 5, 6, 7, 8. Those are our events that are greater than 2. So the probability that a number greater than 2 is rolled, well, let's count them up. How many of those events would make us be successful? 6 of them. Out of a total of how many sides? 8. That's a 3/4 chance, which of course is 0.75 or 75%. Okay, I don't want you to do this one. Ignore it. We'll talk about that one on the next lesson. And so what I want you to do now is just go to a quick, this will be your exit ticket. So I'll take a look if you were following along on your Desmos. You should have just copied those things in. And now this is your chance to try this on your own. We have another problem with marbles, and then we have something with a spinny wheel. I want you to think about that one. See what you can come up with. Okay, best of luck to you, Michael. Let me know if you have any questions.